Hello everyone, my name is Chi and I'm the Alpha Engineer from Aviation Australia. Today we are going to continue our topic about the test and measurement. Today's topic is more focused on instrument control. Before we do the deep dive into the radio frequency, I want to show you some bread and butter of the instrument control. Because of the current situation of COVID-19, most of the international students or engineers have very limited access to the labs. So in this video, we are going to show you how to log in your PC remotely and use your PC to control the instrument with the existing software panel, or you can even use your own software. Hope everyone who is watching this video healthy and safe. Let's get into it now.
As you can see in our lab, we have quite a few instruments here. In front of you, we have a AWG. We also have the spectral analyzer, oscilloscope, and also the power supply, VNA, digital multimeter. So pretty much everything you need for electrical and electronic workbench. There is also a PC connecting all the instruments together and show you the result on the big screen. You can change the instrument setting from the PC as well. Now let's see the setup. This is the two-channel signal generator. We use a splitter to split the first channel output to the spectral analyzer and the oscilloscope at the same time. The second channel output channel connects to the oscilloscope channel 2 directly. Here are the software panels for the instrument. We have the software panel for the AWG, for the spectral analyzer, and the oscilloscope. You can easily see the result from the screen, and you can change the instrument setting from the PC as well. Let's have a close look of the signal generator and the software panel from the PC. Before we do that, let me quickly change the signal we are generating from sine wave to square wave. I'll explain the reason later. We can do it from the PC software. Go to the square wave. You can specify the frequency and the amplitude, and then generate the waveform in the software. But please note that the signal generator is not updated yet, because we haven't downloaded the waveform yet. So we got the waveform ready, and we have to download it to make it work. And so go to download. Maybe you can't see clearly in the screen, but doesn't matter. We will have a close look later. Okay, you can see the result updated from the spectral analyzer and the oscilloscope. The reason I want to use a square wave as an example is you can see the difference and the connection between the time domain and the frequency domain. In the time domain, we have a very sharp rising edge and a falling edge. And in the frequency domain, we can see a lot of higher frequency components in the spectral analyzer. We can see more power in the even times frequencies and less power in the odd times frequencies. And that result actually matched what we learned from the serial of signal. Okay, now it's time to have some fun and make some noise. Now you can have a closer look of the software panel. In the software panel, you can easily generate a sine wave, saw wave, square wave, different kind of waveform. And you can also manipulate your own waveform if you want. And you can also generate a noise. So go to the waveform and scroll down noise. So why are we generating the noise? Because no matter sine wave or square wave, those are the periodical signals. So we want to generate some random noise and see what happens in the oscilloscope and the spectral analyzer. Okay, when we click noise, and you can specify the sample rate and the frequencies and the amplitudes. We'll make it into 200 milliwatt, and we can click preview or press OK to get the waveform ready. So we have the waveform already, As I mentioned, it's not updated until you download it. So let's download it to the waveform generator. Go to download. If you have multiple one, you can choose one, and you can choose which channel you want to download. Let's see, channel 2. Okay. Okay, it's done. Now let's see what happens on the spectrum analyzer and oscilloscope. We can't see anything here because even the waveform is updated with the latest waveform, our noise waveform, but the output is not enabled. So we can enable that either from the software or from the button. So we can press the button. Okay, and we can see the spectrum analyzer. The noise flow rises about 20 dB, and in the oscilloscope we can see the update. That's the time domain waveform on the oscilloscope you can see. But actually there is no much information in the time domain waveform because you can only see some random noise, but it is a noise or it's a periodic noise. So what kind of noise it is, you never know until you see the spectrum analyzer. In the spectrum analyzer, we can see it's white noise because we can't see any significant peak in the spectrum. And in the subfront panel, we can easily set the frequency range to a wider span, so we can see a better look of the full span. We can see it's not a perfect white noise because you can see the spectrum is not really flat, but it's perfect enough for most of the application. Now we have tested sine wave, and we have tested a square wave and the noise, and we are going to do more tests about some more complex signals, like modulated signals. Now we have a perfect sine wave here. You can see it's a perfect single tone from the spectrum analyzer, and you can see the time domain details in the oscilloscope. Now let's do some modulation based on it. You can do it from the PC or press the button. They are essentially the same. So let's press the button, and boom, you have the AM modulation here. We can also have the AM or FM or pulse or digital modulation like a QPSK or COM if you want. You can see the spectrum changed from single tone to 3 tones. The new frequencies are actually the sideband of AM, and you can see the signal information from the time domain. That's a 20 kilohertz sine wave we modulated based on the carrier. Today we show you how to use PC to talk to different type of instrument. All the testing we have done here can be done remotely. As long as you can log into the PC, you can do whatever you want. Maybe someone will say, I don't like the software panel from the vendor. Can I make my own software to integrate all the instrument with my own design? Absolutely. I would recommend National Instrument LabVIEW because most of the instrument from Siglent will provide LabVIEW drivers. I also use Microsoft.NET or Python sometimes, but I found LabVIEW is the easiest tool when you want to create a graphic user interface for the instrument control. Here is an example for the user interface I created for the remote lab. In this software panel, we integrate oscilloscope, digital multimeter, arbitrary waveform generator, and the DC power supply. So you can use this software panel to control all the instruments remotely. If you like this design template, just shoot me an email, and I can send you the LabVIEW design layout. If you like our video, it will be much appreciated if you can subscribe our channel. See you next time.